Hi everyone. Today we are presenting DeepSTEP, a deep learning based spatio-temporal end-to-end perception for autonomous vehicles. This work was presented at IV 2023 and is a joint research work of the Technical University of Munich. What you see in this video is that two cars racing against each other. The green car is overtaking the blue car, and you will now see the blue car spinning out. The reason for that is that here we have an issue in the perception. If we look in the data, we will see quite clearly that the blue car, our ego vehicle, is trying to detect, to perceive, and to predict the other vehicle's behavior. What we see here is that we correctly detect the other orange vehicle, but we have many ghost objects around them. We have objects on the left, on the right, behind, and here in gray, we have one object that confuses our ego vehicle so much that this is spinning out. The reason for that is not only a poor perception, it mainly is based on the behavior of a modular approach for autonomous driving software, which consists of perception, planning, and control. Since here we need to perceive the environment, then provide a dynamic object list, and then only can plan the path and control the vehicle, we will get many issues here. We define, based on this motivation, that we have a high impact of perception errors on downstream modules. We say that connected modules are necessary. Number two, we see that many times sensors are decoupled. We say that intelligent deep sensor fusion is necessary. And number three, we will see here that manual tuning is quite error prone. We say that an end-to-end learning-based architecture is necessary in order to avoid these issues. When we're looking at the literature in the world of 3D perception and perception for autonomous vehicles, we see quite a difference of people arguing between 3D detection and bird's eye view detection. We see people arguing between single and multimodal sensor perception. Number two, we see map-based approaches and mapless approaches for creating an environment. And we see a discussion about the possibility and scalability of these different algorithms and methods. When we read out in the related work section, we provide the following research gaps. Number one, we need an end-to-end perception pipeline that is using multimodal sensor data. Number two, we need an end-to-end perception pipeline that is integrating the temporal domain. We need the time aspects for our sensor fusion. And number three, we need an end-to-end perception pipeline that is enabling the information exchange between task-specific modules. And by defining this research gap, we present now in our methodology our DeepSTEP concept idea. DeepSTEP is a new architecture that firstly provides the multimodal sensor data, and secondly the spatio-temporal deep fusion network in order to create a more robust and reliable environment representation. Our DeepSTEP concept architecture consists of the following individual modules. Number one, the sensor inputs. We rely here on radar, camera, and LiDAR data. In our case, we want explicitly have the multimodal sensor fusion. The sensor fusion is then done in the first of all sensor individual encoder. By providing for each individual sensor the latent space, we have then in the third part the chance to have a spatio-temporal deep fusion network that is fusing together the information based on temporal and spatial domains of the individual sensor. Based on that and the decoder architecture, we have the chance to create different perception heads and different perception outputs, for example, object detection or the local mapping. Ultimately, we will now create a new environmental representation, and therefore, this is our idea, our concept idea called DeepSTEP. Unfortunately, this work is currently work in progress, and we will having the first prototypes running, but we were able to create the first discussion. Number one, This setup allows us a reduced complexity because we have fewer modules. Number 2, we will leveraging here the temporal domain and the multitasking. We create scenario awareness based on the temporal domain, the spatial domain, and the multimodal sensor fusion. And number 3, we have the chance now to enable a sensor sensitivity analysis and to discuss which sensors are really needed in which environments. Our next steps are to create a data set with our own research vehicle, TOM Edgar, and to implement the DeepSTEP architecture on this vehicle. We set up a benchmarking environment consisting of software in the loop and hardware in the loop environments to test the DeepSTEP architecture in real-world application. Thank you very much for your attention. If you want to learn more about the paper or about our lab, please follow the following links. Thank you.